Hey guys, this video is to just go over the answer key for this review packet. The review is essentially a combination of everything that we have videos of already. So hopefully you've been watching the other videos, checking your work, and improving on your skills. So the first thing we have to do on this top section is to simplify each radical expression. Now it's important that we realize that in order for something to be simplified, you have to take out any perfect squares from these square roots, and you also have to remove any radicals from the denominators. So to begin this first example, I have the number 112. So I'm going to think of that as 2 times, well, 50 is half of 100 and 6 is half of 12, 56. 56 is 2 times 23. So my prime factorization is 2 times 2 times 23. So the square root of 112 is the same as 2 times 2 times 23. 2 times 2 is a perfect square. It's 4, so that can come out. 23 remains inside, no perfect square there. 125 is 25 times 5. So really, you might be able to just simplify right from there. But I have 5 times 5 times 5. That is the prime factorization, or 5 to the third, of 125. Here is my perfect square. That's 25. So the square root of 25 is 5, and the other 5 stays inside. So far, we are flying here. 234, it's an even number. These numbers really shouldn't be too bad to break down. Half of 200 is 100, half of 30 is 15, and half of 4 is 2. So 117, 117. Now I'm noticing 1 plus 1 plus 7. Well, when you could add your digits and get 9, that tells you that this number divides by 9. How many times does 117 divide by 9? 9 goes into 11 once. Here's 9. There's 2, 7. 9 goes into that. 13. So what does that tell me? 117 is 9 times 13. And this guy right, not 2, sorry. This guy right there is 3 times 3. So that means 234 is 2 times 3 times 3 times 13. Where's my perfect square? 3 times 3, that's 9. And what's the square root of 9? The square root of 9 is 3. What's left inside? 2 times 13, which is 26. Done. Next, 2 times square root 6 times 3 times square root 10. So, sorry, it's a little crooked here. So what does that simplify to give us? Well, first thing, sorry, I'm just adjusting the focus here. 2 times 3 is 6. Square root of 6 times square root of 10 is square root of 60. But as I explained in class, we don't want to make things bigger just to make them smaller. We're going to break it down anyway, so don't even bother writing 60. 2 times 3 is the 6. 2 times 5 is the 10. Do we have any pairs? Sure do. 2 times 2. 2 times 2 is 4, which is a perfect square. Square root of 4 is 2. That means that that 2 comes out and multiplies by that 6. 3 and 5 stay inside. That's 15 when you multiply them back. Final answer is 12 square root of 15. Next example. Always try to reduce things if you can before you begin. 27 is 3 times 3 times 3. In class, I mentioned how it's really good to know 2 to a power and 3 to a power up until a certain point, because it's going to help you move a lot faster on a lot of these examples. 48, well, that's 3 times 16. It's a really good one to know. If it takes you a little longer and you break it with 2's, then so be it. 16, well, you know that that's 2 times 2 times 2 times 2. There's that 2 to a power again. Okay, now I can reduce 3 and 3 on top. Square root of 3 over square root of 3 is 1. Now up here, I have the square root of 3 times 3. The square root of 3 times 3, or the square root of 9, is 3. If it began in the numerator, it needs to stay there, okay? Here, well, all that's really left is that square root of 16, or 2 pairs of 2. That comes out and that comes out. 2 times 2 is 4. I don't know why I drew so much fraction bar. There's my answer. Next example, 32 is on top. That's 2 to the 5th. There's that again. Like I mentioned, it's really good to know 2 to a power and 3 to a power. 96, well, 90 divided by 2 is 45. 6 divided by 2 is 3, so that's 48 times 2. 48 you have right there. Same number. So 96 was 2 times 48, and 48 was this guy right over there. 3 times 2 times 2 times 2 times 2. Again, we can simplify. Maybe reduce it right away. Either way. 1, 2, 3, 4 2's. 1, 2, 3, 4 2's. One more 2 over there, one more 2 over there. That leaves me with a 1 in my radical on top. The square root of 1 is 1 over the square root of 3. Now we need to rationalize our denominators. I showed you a couple ways. I'm going to just kind of say to myself, well, I have 1, 3, I need 1 more. If I put 1 on bottom, we put 1 on top. What does this become? 1 times the square root of 3, just square root of 3. What's the square root of 3 times 3? It's 3. If it doesn't work out to get rid of the radical, you aren't doing it correctly. Okay? So there is the whole top half. It just took us a few minutes, and I explained it out loud, which sort of slowed me down. Next, I have 192 here. I need to factor this, but again, the directions say solve each quadratic by factoring. It doesn't mean factor and call it a day. So 192, negative 192, basically that's my A times my C, 192. That's not too helpful right now. That doesn't look like it's going to give us a 4. How about 2? Well, half of 200 is 100. Half of 8 is 4. So 2 times 96. Lucky for us, I just broke up number 96 over here. So I should have a good idea of what it looks like. Why is that helpful? You need to know that that will help you out a lot. I mentioned that a bunch of times in class, and I know people were resistant because they thought I was being silly. You know, like, why are you writing all these extra numbers down? I am saving time for us. 2 times 3 times 2 times 2 times 2 times 2. This is 96. I need 2 times 96. So I'm just going to keep all my 2's together. So I'm just going to rewrite this a little bit. 2 times, how many are there? 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So altogether I have 6 2's and a 3. That is what makes up 192. This is going to help me out right now. Next factor pair. 3 times whatever that is. That's 2 to the 6th. Again, can't stress it enough. Good to know. That's 64. Next, 4. Can I make a 4 out of this? Yes, right here. If I take 4, what's left? Well, 3 times 2 is 6. I always start with the odd one if I can. 6 times 2 is 12. 24, 48. 4 times 48. I cannot make a 5 out of this. Can I make a 6 out of this? Yes. I'm just going to underline a little, erase a little bit so I can underline some more. Can I make a 6 right there? What's left? 2 times 2 times 2 times 2 times 2. 5 of them, which is 32. So that is 6 times 32. I can't make a 7. I can make an 8. 2 to the 3rd power is 8. 3 times 2 is 6, 12, 24. That means 8 and 24. Can I make a 9? No. Can I make a 10? No. 11, 12. 6 times 2 is 12. So if that's 12, 16 is what I'm left with. 12 and 16. And it looks like we may have found our winner right over there. Okay? So I need B to equal 4. A lot of the time, you can use numbers that are already on your paper, okay? You're not trying to reinvent the wheel here. So B is equal to 4. So if I'm factoring x squared, my first term stays the same. I use a pair of numbers to split up my middle number. I need a positive 4. That means my 12 will be negative and my 16 will be positive. Minus 12x plus 16x and minus 192 is 0. Do not lose your equal sign. It cannot magically turn into an expression. I'm also going to separate my work over here so I don't get too messy. Some of you could jump right to the answer. Normally I would, but I'm going to elaborate. Here I'm grouping. I'm going to take out my greatest common factor here, which is x. I'm going to take out my greatest common factor here, which is 16. If you look right here, 16 times 12 is 192, right? Also, if this is a plus sign, essentially this gets a plus sign as well. X is going to factor out. I'm going to factor that out. I'm dividing it out. So what's left? X minus 12. The plus 16 is going to factor out. What does that leave? If I divide it out, x minus 12, 0. Again, you have a greatest common factor of, now, x minus 12. That means that we can factor out an x minus 12 from this entire first part and from this entire second part, okay? What do I mean by first part and second part? This whole thing is the first part. That's the second. The greatest common factor is x minus 12. So if I factor out x minus 12, I'm left with x plus 16. Again, it's still equal to 0. We have to solve. That's the whole point of this. So from there, again, I'm going to block off some of this work because it's in the middle there. What am I going to do? I'm going to show my work. I'm not randomly going to write a digit on my paper and call it a day. Normally, I would like these side by side, this and this work, but my work is funny. So x equals 12 is one answer, and then x plus 16 is 0, so x equals negative 16 is another answer. Done. You have two solutions right there. Some of you could have jumped to that very quickly if you know your times tables super well. And if not, then you have to do something like this sometimes, okay? Next example, A, C method again. What is 15 times 12? Well, if you know that this is 3 and 5, and you know that this is, say, 3 times 4, you could break it up differently if you'd like. 5 and 4 is 20. 3 times 3 is 9. Well, what's 9 times 20? Is that easier for you? Sure, that's 180. While I'm doing this, I'm also seeing a prime factorization again. That might help me with my list on the side again, okay? So again, I'm going to write 3 and 5. That's the 15. I'm going to write 2, 2, and 3. That's the 12. So I need something to multiply to give me negative 180, and then it needs to add to give me 11, okay? So I'm going to start with 1 as always, 1 and 180, 2 and 90. Those should be okay. 3 and 60, even that should be okay. If you did 3, I promise the rest of this is 60. 4, yes, because 4 is right here. That's 15 times 3, that's 45. 5 is right there, so that means 5 works. 5 times what? 3 times 3 is 9, times 2 is 18, times 2 is 36. Is there a 6 here? Right there. 6, there it is. Times what? 10 times 3? 30. Ooh, sorry, I'm making this. 30. Can I get a 7 out of this? No. Can I get an 8? No. 9. Yes. 9 times 4 times 5, we said was 20. So 9 times 20. Can I make a 10? Right there. 10 times what? Well, 10 times 18. Can I make an 11? No. A 12. 3 times 2 times 2? Yeah, that's 12 times 15, which is what I started with. So 12 and 15. And that might be the end of the line for us. I think we actually passed the answer before, sorry. B equals 11, and I believe that we have that right over there. That would be a positive 20 and a negative 9 if I wanted to split this up, right? Positive 20 and negative 9 is positive 11. We leave our first and last the way they are. 15x squared minus 9x plus 20x minus 12 is 0. We have 4 pieces. That's your FOIL, first, outer, inner, and last. We're working backwards to get it into the parentheses, get it into factored form. Make sure you're paying attention to what method it asks, okay? These down here are quadratic formula, so be aware. Greatest common factor is 3x. Greatest common factor is 4. The second one always gets the sign in the middle, so plus, okay? I'm going to factor out 3x. Sorry. That's going to be a 5x. I'm basically dividing, minus 3. I'm going to factor out the plus 4. That's going to be a 5x. That's going to be minus 3 equals 0. Again, I have a situation like before. This is my first part, and that is my second part. What do both of these parts have in common? This is identical. If it's not identical, it's either not factorable or you just made a mistake, okay? So from here, I'm going to factor out this yellow, which is 5x minus 3, and that leaves me with a 3x plus 4 inside. No, I randomly changed pen color, sorry. Then, again, you solve. 5x minus 3 is 0. 5x is 3. X is 3 over 4. 3x plus 4 is 0. 3x is negative 4. X is negative 4 thirds. Okay? So right there is our one answer, and there is our other answer. Okay? Now on the bottom over here, we are asked to solve, again, we're getting answers here. We're asked to solve by the quadratic formula. So, sorry, I'm just adjusting the paper. I'm also going to go over here and kind of block off this scrap work, so it's sort of separated a little bit. Okay, quadratic formula. First and foremost, you need to know what the quadratic formula is. If you don't know, you can't use it. Quadratic formula should start with x equals. It shouldn't just be an expression. The formula should tell you what you're finding, okay? X is negative b, or opposite of b. So if it's negative, you make it positive. If it's positive, you make it negative. Plus and minus. Square root of b squared minus 4 ac all over 2a. This radical should, the square root symbol, it should go all the way over the roof of this, and your division bar should really run exactly where mine is, okay? Next, we want to think smarter, not harder. I did a lot of number prime factorization and breaking down a lot of numbers for you guys earlier in the unit because I want you to make your life easier. So you may notice me doing a few tricks here, okay? X equals, you don't have to do the tricks. By all means, you could do it long way if you'd like, but I'm telling you now, it's really time consuming. Negative b plus minus the square root. B squared is 6 times 6. In my head, I'm just writing it like this. In my head, I even know that's 2, 2, 3, 3. 2 and 3, 2 and 3. I promise this does come in handy. Minus 4a, c is negative 9. Right away, minus, this will become negative, so I can just ignore that negative and make that a plus. This does not turn into addition, that's positive. There's a difference between positive and addition. Make sure you're keen on that, okay? All over 2 times a, so 2 times 8. Okay, I didn't do any multiplication yet. Again, I'm going to zoom in a little so that we really see what's happening here, okay? This is 2 times 3, 2 times 3. This is not 2,323, okay? This is 2 and 2 for 4. 8 is 2, 2 and 2. And 9 is 3 and 3. If these numbers are too big for you for some reason, we're not going over this stuff for nothing, okay? What is your greatest common factor? I'm going to kind of separate it into color over here. What's my greatest common factor out of that and that? You can look at it that way, or you can look at it down here. Maybe up top in the pink would have been fine because you right away see 36 and 4 and 9 is 36, but next time it might not be as easy. So you would say, oh, I could take a 2, a 2, a 3, a 3, a 2, a 2, a 3, a 3. So carefully, I'm just showing you a technique. You don't have to do it this way. This might be a big lifesaver for some people. When you factor out, you are factoring it out of this, but not out of the radical. So I'm pulling this 36 that I see right here. 36. If I take a 36 out of that, what's left? The answer is not 1. I'm sorry, the answer is 1. It's not 0. It's 1. You don't say nothing, because what would you distribute the 36 back to, you know? Now, the 4 and the 9 came out, or the 2, 2, 3, 3 came out, okay? This is what I really used to make that 36. So what's left? 36 came out. I'm left with an 8. All over 2 times 8. I guess I'll write 16 for right now. X equals, okay, 8 plus 1 is 9. I'm just rewriting an extra step. Square root of, so I have 36 times 9 in there. If you have the square root of a product, okay, you could take the square root of each part. So you're going to do that next. So there's the 16. Square root of 36 is 6. Square root of 9 is 3. So it's negative 6 plus minus 6 times 3. You have to multiply first over 16. 6 times 3 is 18. Then negative 6 plus 18 over 16 and negative 6 minus 18 over 16. Negative 6 plus 18 is, sorry, I'm a little squashed, I'm going a long way, 12 over 16. Both reduced by 4, I get 3 over 4. Negative 6 minus 18, I get negative 24 over 16. They both reduce by 8. That gives me negative 3 over 2. So those are my answers. Again, you may have done it differently. I'm just showing you a trick. But think about the things I showed you, and I hope that they help you out, okay? Next, I have another example. I already wrote the quadratic formula once here. You need to memorize it. I suggest you write it again. I don't need to memorize it, so I'm not going to write it again. X equals, now acknowledge, A is equal to 5, B equals negative 4, and C equals negative 7. So X equals opposite of B, plus minus the square root. B squared, negative 4 squared will become positive 16. That negative will go away. Minus 4, A is 5, and C is negative 7, so plus there, and 7. All over 2 times A. Maybe you want to write 10 right away. Go ahead. Okay, what can I take out? 5 and 7 are prime. This has a 4 in it. In fact, this has 2 4s. It's 16. It's 4 times 4. If these numbers were too big for you, if you're going to say, like, these numbers are too big, I can't do them without a calculator, that's not really an excuse because we've gone over so much prime factorization. This 4, I'm going to take 1 out of here. Again, that negative will go away. 4 and 4, I'm going to factor out a 4 because it's a GCF. That leaves me with a 4 plus 5 times 7, that's all that's left. That's 35. 35 plus 4, that is, I'm just going to cross it out and save a step right now, 39. This is multiplication, 4 and 39, all over 10. This 4 under the radical, 2 times 2, I can take that out. I have x equals 4 plus minus 2 square root 39. Now, 39 is 3 times 13, which does not break down more, so you cannot simplify it, okay? 39 all over 10. Reducing, simplifying. I've drawn a pretzel in class a bunch of times, and I've mentioned this pretzel. If you reduce, it's got to reduce from everything. You can't just cross this 2 and 10, or you can't only use the 4 and 10. I'm going to take out a 2 from all 3 places. If I do that, that leaves me with a 2 there, a 1 there, and a 5 there. So I get 2 plus minus, I don't need to write the 1, just radical 39 over 5. Leave your answer like that, and you are good to go. And that's x equals, so boom. There's your quadratic formula, okay? And that's with a lot of talking. Next example. Write varying equations of the line that pass through certain points here. A is that, B is that. First and foremost, automatically, you need slope. Y minus y, so 1 minus negative 2 is 1 plus 2, and then negative 1 minus 4. 3 over negative 5, which we can call negative 3/5. I need slope-intercept form. We talked about this a bunch as well. In order to do slope-intercept form, we should probably start at point-slope form. Y minus y1 equals m, not probably, basically definitely. You don't have to, there are other ways, but I recommend this, okay? Y minus y1 is m times x minus x1. Y minus y1, I'm going to pick an ordered pair, whatever one you'd like, okay? I'm going to pick the one with 1. So y minus 1 equals negative 3/5 times x plus 1. That is not slope-intercept form. I need to get this to look like y equals mx plus b. That is slope-intercept form. How do we get there? You manipulate what you have. I'm going to distribute. Y minus 1 is negative 3/5 times x is negative 3/5 x minus 3 over 5. Add 1 to get the y alone. The 1, I'm going to make that into 5 over 5, common denominator. That means we get y equals negative 3 over 5 x. Remember, this is negative and this is positive, plus 2/5. That's slope-intercept form, finito. Standard form needs to look like this. If you don't know them by name, you can't answer the question correctly, so you need to know what things are called, okay? I don't magically put numbers in place. This b is not this b, and I've mentioned that before. You manipulate this, so we're going to, let's clear out the fraction. So I'm going to rewrite my problem down here, so we don't make mistakes, and we'll still have time if we're doing things right. Times 5 to everything. That is my least common denominator. In class, we address this. To clear out fractions, decide what your least common denominator would be, and you multiply everything by that. That gives me 5y equals, here it reduces, negative 3x, here it reduces, plus 2. Don't say 10 over 5 first, you're wasting time. Now I'm going to add 3x to both sides, and I'm essentially good to go. 3x plus 5y is 2. We want all of our coefficients to be integers, and check, and I want a to be positive, check. We are doing great, okay? Graph by finding intercepts. We mentioned that also. We went over that in class. Finding intercepts. I'm going to cover up the 3x. Basically, I'm plugging in 0 for x. I'm getting my y-intercept, divide by 5. Y is 2/5. So 2/5 is some itty-bitty guy right here. Now, nobody says you have to leave these tick marks the way they are. Maybe you want to move 2/5 to somewhere else. Maybe you make this, each tick, 1/5, 2/5, 3/5, 4/5, 5/5. You can do that. So let's deal with that in a second. So my y-intercept is 0, 2/5. I'm going to see what my x-intercept is first. Cover up my 5y, plugged in 0 for y. 3x equals 2, x equals 2/3. X-intercept is 2/3, 0. Again, we can change these tick marks, okay? So I can make each of these thirds. I can make each of these fifths. It really doesn't matter, okay? I can make them all 15ths if I want, whatever I want to do. So I just put these graphs in. If you put them accurate, fine. You want to put 2/3, you want to put 2/5, and then you draw your line from there. Sure, you can do that, okay? If you did, do it to scale. 2/3 would be right about there. 2/5 would be right about there. It's a little hard to draw the line. I mentioned this to a few people who came for extra help, and I mentioned this in one of the videos. The opposite of A over B is your slope. If you have a point, any point, where else do I have points? Guess where? Up here. 4, -2, -1, 1. You can add to my graph and just make it a little bit fuller. 4, -2, -1, 1. You see I'm filling out a few more numbers to add to my graph. Here's down 3 over 5. I could add down 3 over 5, up 3 over 5. Okay, so those are my intercepts. I showed that I found them, but now I'm just going to do my best so everything should make sense and we are good to go. Okay, you don't want to not do the right way, but you could add a few details to your graph. All right, next, find the intersection. Really, on the assessment, you can use any method you want. I'm going to show you both quickly. So here I'm given this by substitution. I can sub that in right there. A lot of people like to call that setting them equal to each other. Not really a thing. We shouldn't really call it that, but some people do. So here we are. I need to solve for x. So this is me using substitution. I'm going to clear out my fractions, times 2 everywhere. That's negative x minus 6 equals 6x plus 4. I'm going to add x over here, 7x. Subtract 4, negative 10. Sorry, my ones are something weird. Divide by 7, x equals negative 10 over 7. Now I can get the other value however I'd like, and then I'll write my ordered pair down over here. Negative 10 over 7, comma. Now, fill it in wherever we want. Makes no difference, really. I guess I'll fill it in here so my 10 and 2 can reduce. I don't know, that was fun. Y equals negative 1 over 2 times negative 10 over 7 minus 3. Negative and negative become positive. 2 and 10 become 5 over 1. 5 over 7 minus 3, which is really how much over 7? 21 over 7. 5, take away 21, negative 16 over 7, and that is what my y value equals. So right here, negative 16 over 7. By elimination, I could just eliminate right now, but I guess I'll go about it a little bit better. This equation is y equals 3x plus 2. I could move some things around if you want it in standard form. That's a little extra, but let's say y equals, means I bring the 3x over. Negative 3x plus y is 2. Now, this equation, I already multiplied it by 2 right here, right? That's 2y equals that. Can you all see that? This times 2, negative x minus 6, and that's 2y. I'm going to put it over here. 2y is negative x minus 6. I need it to look like that, though, so I'm going to add the x over, so I have x. Then I have plus 2y equals negative 6. Now, let's even multiply that top equation. I'm just saving room here, and I'm doing an extra method. So negative 3 times 2 is negative 6. So I'm shorthanding it a little. So I apologize, but you should be able to still figure that out regardless. And then 2 times 2 is 4. These are the same sign. If I add them together, I get 4y. It doesn't eliminate. But if I subtract my whole bottom equation from the top there, I can eliminate y. What is negative 6x minus x? Negative 7x. 2y minus 2y, gone. And then 4 minus 6 is, or minus negative 6 is plus 6, so that equals 10. Okay, from here, to get x alone, we divide by the negative 7, and as you see, we end up getting x equals negative 10 over 7 again, and then you would just go ahead and you really could just substitute back in the way we did before to get the corresponding y value. You don't need to use elimination again, okay? We talked about that in class. Graph to verify. I didn't give you any way to particularly graph these, so we could really go about any way you would like. Y equals 3x plus 2, so here's 2. Up 3 over 1, up 3 over 1, down 3 over 1 to the left, down 3 to 1, okay? So I have this. I'm just going to draw as neatly as I can without a ruler. I apologize. And there we go. And the next one is negative 1/2 x minus 3. So there's negative 3, down 1 over 2, down 1 over 2, and so on. And my point of intersection should be both negative values, which it is, so that's good. Negative a little more than 1, a little less than negative 1 really, and downward between 2 and 3. So yes, we look good. Our answer makes sense. We have verified. Ooh, sorry, I kind of cut that off. Okay, sorry. Next. Again, by substitution, by elimination, by substitution, by elimination. I warned you in class already, you can use any method. So if we're reviewing right now, I'm going to just be a little bit more efficient to shorten the video, okay? So I'm going to use substitution for this one because to me it makes more sense. I will fill this in for y right there. So y, oops, I'm sorry, I'm writing y over. Let's save some time. So I have 3x plus 5 times 1 over 4, x plus 3, close, equals 8. 3x plus 5 over 4, x plus 15 is 8. Then let's subtract 15 and then clear out fractions. Maybe I'm going to do them at the same time, maybe not. So if I subtract 15, I get a negative 7 over here. Now I'm going to multiply everything I have left by 4. Again, I'm not being the neatest with my work here. 4 reduces with that 4, I get 5x. So that gives me these two to become 17x equals, don't forget, that still has to multiply by 4. So negative 28x equals negative 28 over 17. And then we just fill in to get the y value. Y equals 1 over 4x, which is negative 28 over 17 plus 3. 4 and 28, don't forget that was negative. That's 7. negative 7 over 17, negative 7 over, sorry, I'm cutting off, 17 plus 3. 3 times 17 is 51. That's a good one to know because it's a sneaky little number there that a lot of people think is prime. So that really is 17 times 3, so 51 over 17. Negative 7 and 51 is really 51 take away 7. 51 take away 10 is 41. Add back 3, 44 over 17. Fractions are our friends. Make sure you write your answer as an ordered pair. Negative 28 over 17 and 44 over 17, okay? Graph by finding intercepts. I guess we could do that quickly. I'd really rather just get to the other questions, but I suppose we could do that. Divide by 3. So I'm getting my x-intercept right here. 8/3. So 8/3, comma 0. That's one intercept for this graph. And the other one is plug in 0 for x. And we get 8/5, so 0, comma 8/5. Okay. And those both go with that one. And then here, my y-intercept, well, if I still fill in 0 for x, my y-intercept is 3, 0, comma 3, sure. My x-intercept, if I fill in 0 for y, I bring over 3, negative times 4, so negative 12, negative 12, comma 0. I found them. I'm not going to graph them because I want to get to some other examples, but hopefully we can handle that, okay? Next, I'm going to show by elimination for this example. So I want to eliminate. I'm going to make, let's do both of these as 15. So I'm going to multiply everything here by 3. I'm going to multiply everything here by 5. That will make this a 15. So what do I have here? 15x minus 6y equals 27. And then times 5, 15x plus 35y equals 100. They're the same sign. If they were opposites, you would add down and eliminate. They're the same. I'm going to subtract. I'm not going to distribute it. You can if you want, but I'm not going to show it on the paper. I'm going to do it in my head. Those are gone. Now, remember, it goes everywhere. Negative 6 minus 35 is negative 41. Negative 27 minus 100 is negative 73. I was going to say 83 by accident. Caught myself. The negatives will become positive. So y equals 73 over 41. And to get the x back, we are going to go ahead and fill that in. Sometimes numbers are annoying, but it is what it is. That may reduce. I'm not really seeing anything. 41, I'm pretty sure is prime, so I don't think so. I'm going to use the top equation, 5x. 5x is minus 2 times 73 over 41 is 9. Okay, now 5x equals 9 minus 2 times 73 over 41. I brought this whole thing over without doing any math right away. Now 9 is really 9 over 1. I need a common denominator, so 9 times 41 over 41. So now it has a common denominator. That's a minus sign. I'm just doing a few steps to save room. You should really show all your work, though. That's 141 on the, not 141, just one, like, numerical amount of 41s there. And then I need to divide by 5. But dividing by 5 is the same as multiplying by 1/5. So, sorry, circle that. Leave that over there. So here's 1/5. Now, if for some reason you don't have a calculator and you're like, I don't know what this number is over here, do you have to go crazy? Not so much, okay? Could you figure it out? Probably. Could you leave it as like this? Sure, okay? If you must, you must. But I'm going to do some math here. 9 times 40 would be 360. So 9 times 41 is 369. Use reasoning. 2 times 70 is 140. 2 times 3 is 6. So minus 146. And then 5 times 40 is 200. So that will be 205. Look how close we are. Not so bad. 369 minus 100 is 269. So I'm just going to show that a little bit up here because I've been watching how some of you guys are doing some shorthand, longhand math, and I want you to be quicker. That's going to be 269. You could do that in your head. Now you take away 40. That's going to be 229. I need to take away 6. Take away 6. That's 223. So I have 223 over 205. Does it reduce? I don't know. Okay, good enough. It's a tiny bit more than 1, but please don't leave your answer like that. I know it was a lot of work, but let's write our answer as an ordered pair. So I'm just going to fit it down here. Sorry. My solution or point of intersection is 73 over 41. Oops. Whoa. See what I did there? That would have been bad. I was putting my y value first because I found it first. Silly goose. 223 over 205, comma, 73 over 41. There we go. Now from there, if you graph by finding intercepts to see if it makes sense, my intersection should be right around here somewhere. You should have your equations in front of you. 5x is 9, so x equals 9/5. So x-intercept's 9 over 5 right there. The other one is y-intercept is negative 4.5. Negative 4.5 right there. So here, no, is that right? Should be. What's this one? 1 over 1 something, and this is up something. So did I make a mistake? Negative. Negative, that's still positive. Fill that in for my y value. Aha. See, I saw a mistake right here. No one told me. Thanks, guys. Okay, but see how verifying helped me out. So I had to add, and I was silly. So 300, let's go back over here. 69 plus 100 is now 469. Plus 40 is going to be 509. Plus 6 is 515. So that is 515 over 205. Instead, right there. And that's going to change that right there. Not the end of the world. There we go. Okay, so that means over, now it's 2 point something. Okay, and then up 1 point something. So now a little bit more reasonable. Not the most accurate looking graph. It's a little bent and lumpy. I apologize. If 3x is 20 for the other equation, you should have it in front of you. Then x equals, what, 6 and 2/3. So 6 and 2/3 are up there. Y equals a little less than 3. So here's my, oh boy, sorry, a little lumpy. But there we go. Graph to verify. Reasonable answer. I like it. Okay, so that is the end of that example there. And I think that's everything, right? This is just another blank copy. Yeah, so, okay, guys, hopefully that helped you out. And even with all that talking, even with the mistake, we finished this in less than a class period, okay? Good luck.